Part Part 2. Oh joy.
Feeling bent out of shape? Come on in and get on my wavelength.
If you like riddles, I've got a killer for you. Pass me by if you dare.
Hello, I'm Charles Darwin, and I say ask not for whom the coral reef atolls. I'll tell you more inside.
Hello, I'm Roy G. Biv, and I'm just a pigment of your imagination. To find out who I'm not, look for me inside.
The planets look hardly bigger than tiny glowing beads when you gaze at them through an ordinary telescope. They're all just too far away. But optical telescopes, radio telescopes, and space probes have helped us learn a lot more about the planets. Click on a planet and find out how big it is. Mercury is closest to the Sun, only 36 million miles away, and it's rather small. Only 2,900 miles across. Now that's about the width of the Atlantic Ocean. At 88 days, Mercury's orbit is the fastest of all planets. But it rotates so slowly that a day on Mercury lasts 180 Earth days. Venus is almost as big as the Earth, 7,600 miles in diameter. It orbits the Sun every 225 days. It rotates backwards and so slowly that a day is 118 Earth days long. Our planet, Earth, is 7,913 miles in diameter, and it's 93 million miles from the Sun. So if you drove a car at 55 miles per hour, it would take you 193 years to get to the Sun from here. Mars is 4,200 miles in diameter. Now that's a little more than half the size of the Earth. It orbits the Sun every 669 days, and a day on Mars is just 37 minutes longer than an Earth day. Jupiter is the largest planet with a diameter of 86,800 miles. That's nearly 11 times the diameter of the Earth. Jupiter is so far away from the Sun that it takes almost 12 years to complete one orbit, and it only takes 10 hours to make up a Jupiter day. Pluto, the farthest known planet from the Sun in our solar system, is believed to be 3,600 miles across. It's 3.7 billion miles from the Sun, so that the Sun appears only as a bright star in the Pluto sky. You can imagine why it takes 247 years for Pluto to orbit the Sun. Distant Neptune may look tiny, but it's much bigger than our planet. It has a diameter of 31,200 miles and a mass 17 times that of the Earth, and it's so far away from the Sun that its orbit takes 165 Earth years. Uranus is over 3.5 times the size of the Earth with a diameter of 29,400 miles. It orbits the Sun every 84 years. A day is 11 hours on Uranus, but because of the way the planet tilts, winters and summers there can last 21 years. Saturn is a giant, just like Jupiter. It has a diameter of 71,500 miles, or about 9 times that of the Earth. Saturn revolves around the Sun once every 29.5 Earth years, and a day on Saturn is only 10 hours. The truth about our solar system sounds almost like a science fiction movie. 9 planets, all their moons, asteroids, comets, and even dust, spread out across 7.5 billion miles, moving around the bright yellow star we call the Sun. The word solar means sun, and a solar system is a sun and all the planets and bodies circling around it. The Sun's gravity keeps the planets in constant orbit. Our solar system is so huge that the spaceship Voyager 1, moving at about 45,000 miles per hour, would take almost 19 years to go from one end of our solar system to the other. Now, scientists think there are millions of other solar systems in the universe, but they're all too far away to see with the telescopes we have today. Do you know the names of the 9 planets in our solar system? Well, here's a little trick you can use to remember them in order of their distance from the Sun. It's called a mnemonic, which is just an easy way to remember something difficult. Now, a mnemonic doesn't have to make a lot of sense, as long as it helps you remember something. Okay, here goes. My very educated mother just swallowed up 9 pickles. Now, take the first letter from each word in that sentence and substitute the planet name it represents. So, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. Ah, but guess what? Between 1979 and 1999, you'll have to come up with a slightly different mnemonic. Why? Because Pluto's orbit is crossing inside of Neptune's, which means that Neptune, not Pluto, will be the farthest planet. People have wondered for centuries what the planets look like up close, but it wasn't until Voyager and other spacecraft sent back pictures that we really began to find out. Click on a planet and see for yourself. Pluto is small and light and looks like a gassy snowball. The average temperature on Pluto is minus 382 degrees Fahrenheit. But it's a very bright planet because of the reflection of the Sun off its icy methane gas surface. Because it's so far away, it looks like a faint spot, even in the strongest telescope. Neptune is so far away that it's 1 billion miles from its neighbor Uranus. From 1979 to 1999, Neptune, not Pluto, will be the furthest planet from the Sun. That's because Pluto's orbit crosses inside of Neptune's, leaving Neptune further away. In the past 20 years, we've discovered that Uranus has rings like Saturn. In fact, Uranus has 11 of them, mostly carbon dust and ice, and we may find more rings in the future. We used to think that Uranus had only 5 moons, but in 1986, Voyager 2 showed us 10 more for a total of 15. There are as many as 1,000 rings around Saturn, most of which are less than 1 mile wide. These rings stretch out for 170,000 miles. The planet is made up mostly of hydrogen and helium with only a small solid core. There hasn't been any life detected on Mars, but there are many volcanoes, canyons, polar caps, and craters. The color of daylight on Mars is salmon pink, like the color of the Earth's sunset. Now that's because light is filtered through iron dust particles in Mars' atmosphere. Jupiter is the largest planet. It has a powerful magnetic field and is made up mostly of gases, primarily hydrogen and helium. The distinctive red spot that can be seen on Jupiter is a huge cyclone-type storm that's been going on for 300 years. The red spot may look small, but it's actually 3 times the size of the Earth's diameter. Earth is our home planet, and you already know a lot about its mountains, rivers, and valleys. But most of Earth is water. We've got 140 billion square miles of water and only 58 billion square miles of land. Earth is about 93 million miles away from the Sun, orbiting at 67,000 miles per hour. Mercury is the closest planet to the Sun, so it's very hot there, 806 degrees Fahrenheit. And at night, it gets really cold, down to minus 292 degrees Fahrenheit. Think of it this way. On Mercury, lead would melt in the sunshine and a person would freeze solid in just a few minutes at night. Venus is the brightest planet in the sky and the closest to Earth. The atmosphere on Venus is 96% carbon dioxide. Oddly enough, Venus is the only planet that rotates backwards. So on Venus, the sun rises in the west and sets in the east, the exact opposite of Earth. Thousands of years ago, way before television, people stared up into the night sky and saw among the stars their own kings and queens, and the animals, gods, and heroes in their myths and legends. These patterns of stars that look like connect-the-dot drawings are called constellations. The easiest constellation to see in the northern hemisphere is the Big Dipper. The shape is easy to trace. It's a bowl with a long handle, like a soup ladle. You can see the Big Dipper all night long from most places north of the equator. And if you draw an imaginary line between the two end stars in the bowl and continue that line on, you'll come to the North Star. That's the star sailors used in the old days to set their position because it stays in the same place throughout the night. If you're in the southern hemisphere, it'll be easy for you to find the Southern Cross. Its four brightest stars form a cross that points to the south. Some of the most well-known constellations are the 12 signs of the zodiac. These constellations turn in a slow circle through the sky as the year progresses, each of them prominent during a different month. So they called these constellations the zodiac, which means circle of living things. To find out the myth or legend behind one of the signs of the zodiac, just pick a sign.
Oh, so many. Oh, alright, might as well do it. This is my sign.
A boy and girl were going to be killed as a gift to the gods. But Zeus, king of the Greek gods, sent a golden ram to save them. The girl fell off the ram, but the boy made it to safety. Zeus ordered the boy to kill the ram, and when he did, Zeus placed the ram in the sky in remembrance. Zeus, king of the Greek gods, wanted to court the princess Europa, so he turned himself into a white bull for her to ride on. When Zeus changed back into his normal form, he placed the bull in the sky to celebrate his wedding to Europa. Castor and Pollux were twins who liked to do everything together. So when Castor was killed in a fight, Pollux begged Zeus, king of the Greek gods, to let him be with his brother. Zeus granted his wish and put the twins in the sky together to honor their love for one another. The gods gave the ancient strongman Hercules 12 hard tasks to test his strength. In one test, he had to fight the nine-headed Hydra. A huge crab tried to help the Hydra beat Hercules, but Hercules won anyway. Zeus, king of the Greek gods, punished the crab for helping the Hydra by imprisoning him forever in the sky. One of the 12 tests given to Hercules by the gods was to kill the fearful lion of Nemea, which was a place in ancient Greece. Hercules was victorious and passed the test, and the gods turned the lion into a constellation to honor Hercules' victory. Demeter got herself stuck in the underworld with the god Hades. Demeter's mother tried to get her back, but she only half succeeded. Demeter was allowed to come back for half the year in the springtime. To celebrate Demeter's yearly return every spring, Zeus put a new constellation in the sky which looked like Demeter. It was called Virgo. Two goddess sisters, Aphrodite and Persephone, both loved the same man, Adonis. They kept fighting over who was going to get him, so Zeus, king of the Greek gods, stepped in. He ordered Adonis to spend 4 months with Aphrodite and 4 with Persephone. The other 4 months were Adonis's choice, and he chose Aphrodite. Zeus put the scales of justice in the heavens to honor his own wise judgment. Sagittarius was a centaur, half man and half beast. Centaurs were supposed to have a mean streak, but Sagittarius was gentle and wise. He taught doctors, musicians, and archers, but Zeus, king of the Greek gods, was tricked into killing him. Zeus was so sorry that he placed Sagittarius in the sky to honor the gentle centaur. There's no clear myth about Capricorn. Some picture him like Pan, the mischievous Greek god of the fields who was half man, half goat. Others saw Capricorn as half goat and half fish. In either case, when Zeus was a baby, he drank this goat-fish creature's milk. So when Zeus grew up, he put Capricorn in the sky to remind him of his childhood days.
Oh, that's not too disgusting.
The gods needed a new cupbearer to bring them their favorite drink, ambrosia. So Zeus chose Ganymede, son of the king of Troy. Zeus disguised himself as an eagle, swooped down, and carried Ganymede off to the heavens. Ganymede became the new cupbearer, which is how we see him in the sky. Typhon was an ugly and terrible monster. He spat hot rocks and had huge wings and hundreds of wriggling snakes. He even attacked the goddess Aphrodite and her son. They ran to the sea for safety. Poseidon, god of the sea, sent 2 big fish to rescue them. The fish brought them to safety, and Zeus formed a new group of stars to honor these fish. Later, he killed Typhon with a thunderbolt. But that's another story. There are 2 myths about Orion, a rather rash young hunter. One myth is that he killed a giant scorpion on a dare, and the other says that the scorpion was killed when it came after Orion. Either way, the scorpion was placed in the sky so that everyone would remember Orion's heroic deed. Way back in the Middle Ages, people thought comets were evil signs of coming war or death. Even as recently as 1910, when Halley's Comet passed by Earth, people were sure they were going to be wiped out by poisonous gases. But of course, nothing of the sort happened. You see, a comet is simply a ball of glowing gases with an icy center. It goes around the sun in an elliptical or egg-shaped orbit. And its orbit may be huge, billions of miles into space. But the comet always returns. As it approaches the sun, it drags its tail of glowing gases and particles behind it. But as it passes the sun, it's reversed. So the tail is in the lead, and the head actually follows the tail. This is because the gases that make up 99% of the comet are weak. The sun's rays put pressure on these gases, pushing them away from the sun and in front of the comet's body. As the comet moves away from the sun, it slows down, and the tail loses its glow. One of the most famous and regularly seen comets is Halley's Comet. The last time it visited Earth was in 1985. But unfortunately, it didn't put on the spectacular light show everyone was hoping for. But Halley's Comet has put on some really great shows over the centuries. It was first noticed in 240 BC. Nobody thought to look for it again because people didn't know that comets return at regular intervals. But when English astronomer Edmund Halley was going through old records of comet sightings, he realized that the comets that appeared in 1531, 1607, and 1682 looked very much alike. He figured it was probably the same comet coming back every 75 years, and predicted that it would return again in 1759. Unfortunately, he didn't live long enough to see his prediction come true. But the comet named after him did appear in 1759 and every 75 years since then. And it will return yet again in 2060, just in time for your children and grandchildren to see it. Did you know that the falling stars you've wished on aren't really stars at all? They're actually falling meteors. Meteors are small, solid bodies floating around in space. Some of them are pieces which have broken off passing comets, but most of them are just space debris made of stone, iron, or combinations of different metals. Sometimes they crash into our atmosphere and burst into flames. If they land on Earth, they're called meteorites. Meteors travel toward us for a long time, but we only see them when they're about 60 miles above Earth. Then they start to burn up in the atmosphere and we see a fiery tail. At certain times of the year, for instance in December in the northern hemisphere, you can see what's called a meteor shower. Thousands of meteors flaming as they crash through our atmosphere. Try to catch the next one if you can. It's really a spectacular sight. Most meteorites are no bigger than the head of a pin. Some, however, are large enough to weigh several tons. We're lucky that most of them are tiny little pieces of stone, rock, or metal, because if they were all large, we'd have a bunch of holes in the surface of our planet. Thousands of meteorites fall to Earth each year, and most of them land in the oceans. But we do have some spectacular holes, or craters, made by very large meteorites. There's one near Flagstaff, Arizona, that was made by a meteorite that fell 22,000 years ago. It's almost a mile wide, 3 miles around, and nearly 600 feet deep. That meteorite probably had the energy of a very large hydrogen bomb and must have produced a massive dust cloud when it hit the ground. Have you ever wondered why, when you look at a map of the solar system, there's a much bigger space between Mars and Jupiter than between the other planets? The space is large enough that it seems something should be there. Well, something is there. Not exactly a planet, but what astronomers call asteroids. Asteroids are small celestial bodies, most of which are less than 300 miles in diameter. They orbit the sun just like planets. The first asteroid to be discovered was named Ceres by Giuseppe Piazzi in Palermo, Sicily on New Year's Day, 1801. He was looking for the planet that astronomers expected to find between Mars and Jupiter, but found this asteroid instead. By 1845, 5 asteroids had been found, and since then, not 1 year has gone by without finding more. Scientists think there may be 50,000 asteroids out there. One of the most awe-inspiring sights of nature happens every day: the sunset. Sunsets can blaze red, orange, and purple. But where do these brilliant colors come from? It has to do with the distance that sunlight must travel through the atmosphere, the layer of air that surrounds the Earth. The lower the sun is in the sky, the more atmosphere sunlight must travel through. Although sunlight appears as white light to our eyes, it's actually a mixture of all colors. But the atmosphere has particles of dust, water vapor, and other things in it. As light passes through the air, different colors are scattered by these particles. Our atmosphere scatters blue and green light more than it does red and yellow, so when the sun appears low in the sky, more reds and yellows come through, and we see a reddish sunset. Have you ever looked up on a sunny day and wondered why the sky is blue? The even blue color we see comes from sunlight, the white light that's really made up of all the colors. Sunlight is made up of light waves of different lengths that shine through the atmosphere. These light waves are scattered by dust and air. Blue and violet waves are shortest, and they scatter the most, spreading all over the sky, and that makes the sky look blue. What about the other colors? Well, their longer wavelengths travel straight through, and that gives the sun its yellowish hue. You know that sunlight hardly seems to have any color at all. Yet somehow, often after a storm, that light can be transformed into something magical. A rainbow. Here's how it happens. Sunlight seems to be white, but it's really a mixture of all colors. If you look at it through a soap bubble or a prism, you'll see sunlight broken into all the colors of the rainbow, called the spectrum. Raindrops can act like little prisms, breaking up the white light into one great curved spectrum. That's what we call a rainbow. A rainbow can only be seen when it's both raining or there's a lot of water in the air and the sun is shining. Also, you can only see a rainbow in the early morning or late afternoon when the sun is low in the sky. And you must be between the sun and the rain, with the sun behind you and the rain in front of you. If you want to remember the order of the colors in the rainbow, just think of Roy G. Biv. Who is Roy G. Biv? Well, you won't find him in the Yellow Pages. In fact, it's not a person's name at all. Roy G. Biv is a mnemonic, an easy way of remembering something difficult. Here's how it goes. R-O-Y stands for red, orange, yellow. G stands for green, and Biv stands for blue, indigo, and violet. Indigo, by the way, is a shade of blue, kind of a dark purplish blue. So, Roy G. Biv is really red, orange, yellow, green, blue, indigo, violet, the colors of the rainbow. Have you ever seen a rainbow shimmering in a soap bubble or dancing off a piece of glass? Every color you see is actually a different wavelength of light. Sir Isaac Newton, back in the 17th century, figured out that sunlight is made up of all colors. Now, to see that, you can shine light through a prism, a piece of specially shaped glass or plastic that refracts light. In a prism, the different wavelengths of light are bent at different angles, forming the spectrum, all the colors in the rainbow. So, white light is made up of all the wavelengths in equal proportion. Now, when we talk about the color of an object, we're really talking about the ability of that object to absorb some wavelengths of light and reflect others. An apple is red because it absorbs the shorter wavelengths and reflects longer ones. However, our eyes are only sensitive to red, green, and blue. By combining those three colors, our brain makes up all the other colors we see every day. Although red, green, and blue are often called the primary colors for light, when you're talking about painting, the primary colors are red, blue, and yellow. Why? Because the pigments in paint mix differently than light waves. Here's an easy way to see how different colors mix. Just click on the lights to turn them on or off. To see how paint mixes, just click on the paint can. Fall might be your favorite time of year because you get to see the green leaves turn shades of scarlet, gold, and brown. Have you ever wondered where these new colors come from? Well, actually, they were there all along. You see, leaves are usually green because they have chlorophyll in them. Now, chlorophyll is the green pigment in leaves that traps sunlight's energy to make the plant's food. Sort of a tiny food factory in each leaf. And 2/3 of a leaf's color comes from that chlorophyll. There are other colors in the leaves too, but there's so much chlorophyll that we usually can't see them. In the fall, when the cold weather sets in, the chlorophyll starts to break down and the food stored in the leaves flows out to the branches and roots. As the chlorophyll disappears, we finally get a chance to see all the other colors that were hiding in the green leaves all along. Perhaps you've noticed that some trees don't change color in the winter. For instance, pine trees never turn red or gold. That's because they don't shed all their leaves during the fall as other trees do. Pine trees and other evergreens lose their leaves and grow new ones continually throughout the year. That's why they're called evergreens. She sells seashells by the seashore. But where do all those seashells come from in the first place? Well, seashells were once the homes of sea animals. The most common kinds of shells were once the homes of marine animals called mollusks. Most mollusks have soft bodies with shells outside. The shell is the mollusk's external skeleton and is attached with muscles. The shell is made of limestone from the water, and it grows in size and strength as the mollusk grows. The mollusk has special glands that help it use limestone to build its shell. Some shells are quite colorful, while others are very plain. Shells also vary a great deal in size. Some are so small that you need a magnifying glass to see them, while the giant clam has a shell that can be 4 feet long. More than 80,000 kinds of mollusks have been identified and named, and most, but not all of them, have shells. The best-known mollusks are members of one of 3 groups. The first group is called bivalve, meaning they have 2 shells. Bivalves include mollusks such as clams, mussels, and scallops. Next are the gastropods. Gastropods, also called univalves, have 1 shell, such as the sea and land snails, slugs, and the cowrie. The last group may seem a little unusual because most of these mollusks have lost their shells. This group is called cephalopods. 2 familiar cephalopods are the squid and the octopus, both of which are very advanced mollusks and even show signs of simple intelligence. Have you ever seen a piece of coral at the seashore? Well, you might have thought it was a rock with its hard, sharp surface, but it's really the skeleton of what was once a living animal called a coral polyp. Coral polyps live in colonies attached to underwater bases such as rocks. When they die, their coral skeletons remain. Coral colonies are found in all the seas, but they only build reefs in warm, shallow water. Coral reefs are made of billions and billions of these tiny skeletons. Sometimes colonies of living coral attach themselves to the dead reefs. So if you ever visit a coral reef, don't break off a piece. It could still be alive. Even worse, it may be a fire coral, which is poisonous and can burn your skin. The great naturalist Charles Darwin first solved the mystery of how coral reefs are formed. Darwin knew that undersea volcanoes pushed up to form islands. In the shallow water of these island shores, coral find a perfect place to build reefs. Coral colonies that circle the island are called fringing reefs. Over time, the island may be eroded away. This leaves a large area of water separating the shore and the reef. This is called a barrier reef. Sometimes the volcanic island is eroded below the water's surface and only the coral reef is left. Now it's called an atoll, a ring of coral surrounding a lagoon of water. So the rise and fall of volcanic islands, as well as the changing levels of the ocean, help explain how coral reefs build up and change so much over time. Most people think that the different seasons are caused by the Earth orbiting farther away from the Sun. But that's not the case at all. It has to do with the way the Earth tilts as it moves around the Sun. You see, the Earth revolves on its axis, which is on an angle compared to the Sun. As the Earth orbits the Sun, it stays at this same angle. Sometimes the North Pole is tilted toward the Sun, other times during the Earth's orbit it's tilted away. When the North Pole is tilted toward the Sun, the whole northern hemisphere gets more of the Sun's light and heat, and that makes it summer in the north. At the same time, the South Pole is tilted away from the Sun, so it's winter in the southern hemisphere. 6 months later, when the North Pole is tilted away from the Sun, it's winter in the northern hemisphere and summer in the south. This picture shows you the Earth's position as it orbits the Sun. Click on each Earth to see how the seasons change during the year. March 21st is the vernal or spring equinox. Because the Earth's axis is not tilted towards the Sun on this date, day and night are the same length at the equator. June 22nd is the summer solstice, the beginning of summer in the northern hemisphere and winter in the southern hemisphere. It's the longest day of the year in the northern hemisphere and the shortest day in the southern hemisphere. The autumnal or fall equinox falls on September 21st. At the equator, both daytime and nighttime are the same length on this date, and it's the beginning of fall in the northern hemisphere and spring in the south. Did you know that the winter solstice, the shortest day of the year in the northern hemisphere, is also the longest day in the southern hemisphere? This occurs on December 22nd. See how the North Pole tilts away from the Sun? It's winter there.
The forecast, mostly sunny skies today with brisk easterly winds. Expect a high near 52 degrees.
How do weather forecasters predict the weather ahead of time? They get help from the National Weather Service, a governmental agency with hundreds of official stations around the world. Thousands of independent weather stations also help out. Weather satellites send back extremely detailed photos from outer space showing what sort of weather is developing. Now, from all this information, weather experts can put together weather maps. Forecasters read these maps to find out the direction of the winds, where the clouds are, and where the air pressure is high or low. And with this information, they make their forecasts. For example, low air pressure is a warning that a storm is coming because cold, moist air is moving in to replace rising, warm, dry air. You can find daily weather maps published in your local newspaper.
It's currently 47 degrees.
Weather forecasters read maps to take what's called an educated guess at what the weather will be. Just click on the map and you can learn how to predict the weather too. This line indicates a warm front. This means that warmer air is replacing cooler air in the direction of the half circles. It is often a sign of slow-moving, stormy weather. This indicates a low-pressure area. The warm air here is rising, being replaced by cold air. Chances are a storm is moving in. A stationary front means that there is no air movement either backward or forward. Temperatures and conditions tend to remain the same. This is the sign for a high-pressure area. It generally means clear skies. This line with the triangles indicates a cold front, which is cooler air replacing warmer air. Moving in the direction that the triangles point, it is often the sign of a fast-moving storm. It's a dark and stormy night when suddenly lightning bolts crack open the sky. A few seconds later, thunder explodes like a cannon. Why does thunder follow lightning? It's really simple. Both the thunder and the lightning happen at the same time, but light travels much faster than sound, so we see the lightning first and hear the thunder several seconds later. Light travels at 186,000 miles per second compared to less than 1/4 mile per second for sound. Here's a trick to tell you whether a storm is approaching or moving away from you. During the next storm, just count the number of seconds between a flash of lightning and the thunder that follows. Then do it again a minute or so later. If it takes longer the second time, then you know that the thunder had to travel farther to reach your ears. That means the storm is going away. If it's shorter, then you can expect the storm to continue for a while. Lightning is just what it seems to be, a flash of electricity in the sky. It forms in clouds where water, ice, and dust particles rub together and become electrically charged. The smaller particles are positively charged. They stay on top and in the center of the cloud. Negatively charged particles are at the bottom. The positive and negative charges keep trying to come together, but there's a lot of cloud in the way. Suddenly, they break through the air that separates them, producing a flash, lightning. But what about thunder? Well, when lightning blasts in the sky, it superheats the air up to 54,000 degrees Fahrenheit. And when that happens, the air expands rapidly, creating a large sound wave. And that's what we call thunder. What's so great about the Great Wall of China? Well, to begin with, it's gigantic. It winds across northern China for 1,500 miles and averages 25 feet high. It's 15 to 30 feet wide at the base and slopes to about 12 feet wide at the top. There's a roadway on top with evenly spaced guard towers. The Great Wall was meant to make all of northern China a protected fortress, and was built to protect northern China from Mongol invaders back around 236 BC. It was probably begun in 221 BC by order of the Emperor Qin Huangdi. It took only 15 years to build and is made out of stone and brick. Of course, it went through a fair amount of damage and weathering over the years, and emperors kept rebuilding it. The present wall probably dates from the Ming Dynasty, which was from the 1300s to the 1600s. It's still there today, more as a tourist attraction than a fortification. So, did the Great Wall of China really keep the Mongol invaders out? Unfortunately, no. The Mongols were terrific horsemen. They were brave, headstrong, and pretty much did what they wanted. Despite the wall, there were many invasions of China from the north by Mongols and other barbarian tribes as well. The wall became less a fortification than a dividing line, separating the farming culture of China from the nomadic herding culture of the Mongols. And it still does much the same thing today. It's pretty hard to ignore a wall that's 1,500 miles long. Why can't this famous building stand up straight? Because the builders of the Leaning Tower of Pisa in Pisa, Italy, made the mistake of laying its foundation in sand. Sand is hardly the most stable material in the world. It shifts around a lot. Construction started on this 8-story, 179-foot tower in 1174, and it started leaning by the time they built the 3rd story. The builders tried to make corrections to fix the lean, but when the tower was finished in 1350, it was still leaning. Over the last 100 years, it's continued to tilt a whole foot. By now, it's at least 14 feet away from being straight. Unfortunately, it just keeps tilting, and scientists think that one day the whole thing is going to come crashing down. In any case, it's clear that one of the world's most famous landmarks is also a monument to poor construction. Galileo used the Leaning Tower of Pisa to conduct some of the most important experiments in scientific history. The great Italian scientist used the tower to prove a basic law about the motion of falling objects. Before Galileo, people believed what the ancient philosopher Aristotle had said about falling objects, that heavier objects fall faster than lighter ones. But in the late 1500s, Galileo went to the top of the Leaning Tower of Pisa and tossed off several objects of differing weights. Well, they all hit the ground at the same time. So, Galileo demonstrated that bodies of different weights fall at the same rate of motion. And that's been the scientific view until just recently. Today's sensitive scientific instruments now indicate that heavier objects do indeed fall a little bit faster than lighter ones. What is this strange statue with the body of a lion and the head of a human being doing guarding the pyramids in the middle of the Egyptian desert? It's the Great Sphinx of Giza, and it represents a mythical monster in Egyptian folklore. Lions lived in the desert just beyond the valley of the Nile, and the Egyptians admired them for their strength and beauty. The head is carved in the likeness of the Egyptian kings, who were called pharaohs. The Great Sphinx of Giza started off as a mound of dirt, left over from building the Great Pyramid. It was probably built to honor Khephren, a king of the 4th Egyptian dynasty. The Sphinx stands 66 feet high and 240 yards long, and forever guards the pyramids, the burial place of kings. And did you know that the ancient Egyptians weren't the only ones to build sphinxes? They were also built by the Greeks and the people in the ancient Near East. According to legend, the Sphinx would kill any passerby who couldn't answer her favorite riddle. You want to give it a try? Here goes. What walks on 4 feet in the morning, 2 feet at noon, and on 3 feet in the evening? What's your guess? Well, the answer is a human being. Humans crawl on hands and knees as a baby. That's the morning. Then they walk on 2 feet as an adult, noon, and in the evening, that is old age, they use 3 feet. Why? Because they use a cane. The cane is the 3rd foot. Nobody could answer this riddle, and the Sphinx had everyone scared stiff because she kept killing all the people who passed by and answered incorrectly. That is, until she came up against the Greek king Oedipus. He knew the answer. The Sphinx was so angry that she killed herself. What a sore loser.